So what are those basic PC system parts that we've been talking about? Again, there could be many of them, but we're going to keep it simple. In general, a PC system needs to have a central processing unit, or a CPU, a monitor, a keyboard, and a mouse. We're going to talk in depth about CPUs, keyboards, and mice. We're not going to talk much more about monitors. Remember that the central processing unit, or CPU, is something that we'll be talking about, and it can also be called the case, but we'll get onto that in just a second. When it comes to monitors, keyboards, and mice, we have several different versions and they may look different. Here we can see two examples. On the bottom we see an older model called a CRT. Basically they're big and bulky and they were around for years. But they've pretty much been completely replaced by monitors that look more like the one on the top. Again, they could be different colors, different sizes, but the one on the top is known as a flat panel. It's much skinnier, much lighter, sleeker if you will. They both do the same thing. They allow us to see what's going on the computer or what we're typing, what the computer needs from us, and so forth. Keyboards are input devices that we use, and these are two kind of specialized examples. On the top, it's called an ergonomic keyboard, and we'll talk more about these later, but it's kind of split, a little bit different than a typewriter would be, so that it's easier for people who do a lot of data entry and less wear and tear on their hands. On the bottom you see a gaming keyboard. Now it has all kinds of extra little buttons and it even has red on the keys instead of a typical black and white. This has a lot of extra things specific for gaming. Not necessarily appropriate for a business environment, but if you need to work with gaming and all the different things that have to do with that, this is the perfect keyboard for you to use. Probably the simplest type of hardware that we have is the mouse, and we'll again talk about the mouse in a later section. But a mouse is a pointing device, and we can point and click, and here you just see a couple of versions. They all do the same thing, even though they look very different. All right, let's get into the nitty-gritty, that central processing unit, or the CPU, or what some people call the case or the box. This is the box that sits on your desk or on the floor. It might be upright or it might be sideways. It just depends on what type you actually have. It also may be integrated into the monitor. Some of the computers these days actually put the CPU components on the back of the monitor, making the monitor a little bit thicker, but then you don't have to worry about the box. The CPU is really the brains of the system. This is where all of the computing magic really happens. It has all the circuitry and electronics as part of it. What we can see on this particular screen are several examples of CPUs. They all do the same thing, but they do look very different. On the left is probably your most traditional looking CPU. It's a little bit wider, a little bit taller, very chunky if you will. The second one is a sleeker model, a little bit more narrow, something that we might call a mini tower, whereas the one on the left could be a full tower. The third one is actually a gaming machine, and it has all kinds of nice little lights and things that light up on the inside, makes it more exciting for people who are gamers. And on the right-hand side, we have a very small one that can sit right on the desktop. All of these do exactly the same thing. They have different potential. We'll talk about what that is in just a few minutes, but they're all the brains of a system, even though they're different sizes, different shapes, different colors, and so forth. So what's actually in the box? Well, actually that's pretty easy. The CPU can contain many different components or parts, but the most important parts we've listed here. A CPU has to contain a motherboard. It should contain a hard drive, something called RAM memory, a power supply, a fan, and it could have things known as sound, video, and network or modem cards. We're again going to take these kind of one step at a time. What we won't talk about anymore after this particular slide is the power supply and the fan. Obviously, a computer needs to have a source of power, so there is a plug or an outlet in the CPU, and it also needs a fan to keep all of the components cool. Those aren't things that we normally worry about, though, so we won't discuss them any further. We will discuss these other components, though. Maybe one of the scariest things and the most technical that we'll talk about is the motherboard. This is where we have all of the circuitry. This is the computer's primary circuit board, and there literally can be thousands, if not millions of pieces on this one little piece of electronics. The primary components, though, are the actual computer processor, which we'll talk about in just a second, slots for RAM memory chips, the controlling circuits that allow the computer to recognize what a mouse is, a keyboard, a disk drive, and a printer, and what it should do with it, and then slots for other types of cards that we just mentioned, like sound cards, video cards, network cards, and modems. Probably the most important component, though, of the motherboard, and really of the computer as a whole, is known as the computer's processor. There are many, many different brands, models, and speeds. And the reason I mention this in a fundamentals course is because if you're going out to purchase a computer, you need to know about processors so you can make a good choice. The processor determines how much data can be processed at any one time and how fast it can be processed. Common brands include Intel and AMD, and within those two you also have different models like Celeron, Pentium, Core 2, Athlon, Turion, and Phenom. Many current processors actually have more than one processor in them, and these are sometimes called dual or quad-core processors. So on your computer and on your motherboard, you'll have one processor. But if you have a dual-core processor, it actually has two processors in one, and if you have a quad-core, it has four. But what about the processor's speed? Well, it's not quite as clear-cut as just saying, just tell me what the speed is. Here's why. The type of processor can be faster or slower than the same speed, but a different type of another processor. Let me give you an analogy for that. Let's say that you and somebody else are supposed to both go to the grocery store. You both can drive exactly 35 miles an hour from the time you start till the time you get to the store, so your speed is the same. But if you know a direct route to the store, and your friend doesn't know that route and has to go a little bit longer way, obviously you're going to get to the store faster than they are. This is the same thing that can happen with the processor. Even though technically the processors are driving, if you will, at speed, if they process things differently, then one may actually be slower at processing the same amount of data than another. The speed is determined by how they actually process the data, and that's measured in gigahertz. The bigger the number, the faster it is. Let's look at some examples. When you're buying or looking at the computer's processor, you need to look for several things. First of all, who's the manufacturer? What's the model? How many processors does it actually have? Remember that single core, dual core, quad core we talked about. And then what is the actual processor speed? Let's look at a specific example so you can see how you would compare processors if you were purchasing a computer. I've listed for you 4 actual examples of processors that you can buy. You'll notice that the manufacturer is the same. These are all Intel processors, but they have different models. There's a Celeron 3-core 2s, 2 that are duos, 1 that's a quad, and then a whole variety of speeds. So let's analyze these a little bit. The first one is an Intel Celeron 450 2.20 gigahertz. Now you may not know this, but a Celeron is kind of an entry-level processor, if you will. So just remember right now, it's a single-core processor, 2.2 gigahertz. If we compare that to the second one, it's also an Intel, but this is a Core 2. The Core 2 processors process things differently, so it automatically makes it a little bit faster than the Celeron. In addition, it's also operating at 2.93 gigahertz, which is a bigger number than 2.2. So it both processes things differently, which makes it faster, and its actual speed is faster. So the second one is going to be possibly a better choice. The third processor is also Core 2 Duo. So the only difference between the second and the third is that the first is at 2.93 gigahertz and the second is at 3.33. That would make the third one faster. The last one is still a Core 2, but this time it's a quad processor at 3.0 gigahertz. And this is where it gets a little bit interesting. It is a quad processor, but notice it's a little bit slower. So the question would be, based on the type of computing that you do, what types of activities you're doing, does the quad processor make it faster than the duo, or does the 3.3 gigahertz make the duo processor a little bit faster than the quad? It's not an easy answer. What we actually get in this particular scenario is that either one of the last two are going to be really, really close. If I'm doing some heavy-duty business computing or some things with audio and video, I definitely want to stick with one of these two processors as opposed to the Celeron. Why doesn't everybody just get the higher-end processors then? The reason is, of course, the price. A quad-core 3.0 gigahertz processor is going to be significantly more expensive than a Celeron. But you know what? If you're using a home computer and you're listening to a little bit of music, maybe browsing the internet, doing some word processing, the Celeron processor is going to be just fine. You probably wouldn't even notice the difference between these four processors. It's only for higher-end multitasking where the higher-end processors might become an issue. That's really what I wanted you to know about the processor itself. And I know it gets a little bit technical, but hopefully you can now see that we have hardware, software, and operating systems. Within the computer, we have the CPU or the box. On that, we have the motherboard, and the motherboard contains the processor, and that's what may be important for you, at least initially, when you're going to look at a particular computer. We're making some progress, and hopefully it's not too confusing or overwhelming to understand that we have hardware, software, and operating systems, and that even though it can get a little bit technical talking about motherboards and processors, that there's only a couple of things we have to remember if we're going to purchase a computer to understand what we need. The next thing we need to talk about, though, is computer memory, and this can really get people confused. So let's see if we can, again, take it from the top, make it very general, but also make it so you can understand what computer memory is about. Computer memory is just like yours. You have memory, and your memory allows you to remember or recall information. That's exactly the same thing that computer memory does. A couple of different categories of computer memory include read-only memory, or ROM, and this can't be written to or erased. This is like permanent. It's built into your computer. It's important because that's what contains startup information. Before you even get to all of the other components we've been talking about, when you power on a computer, it reads the ROM memory, and that's what gives it the instructions on kind of how to finish up the startup process. The one that we're more concerned about is known as random access memory, or RAM. This is a type of memory that you can read from and write to. But it is temporary. It's only saved until the computer is turned off. And we'll talk about why that's important here in just a few seconds. It's also important to realize that computer storage is not the same as computer memory. Computer storage is something like the hard drive or a CD. Memory is ROM and RAM. So let's talk about this thing called the hard drive. The hard drive is typically internal, and it's permanent or offers long-term storage. So think again back to yourself. You have short-term memory and long-term memory, and stuff that you need to remember for a long time. Hopefully you've committed to long-term memory so that you can recall it not only in the next few moments, but next year, next week, or next month. Remember that the hard drive is not the same as memory. This is actually considered storage. Hard drives are usually measured in gigabytes, and this is something that has changed over time, but now we measure hard drives in gigabytes. The larger the number, the more storage you have. It's kind of like the number of shelves in a library. Now let's think about that analogy for just a second. If I live in a small town, maybe there are 10 bookshelves in the library. Obviously, that can't hold as much as the Library of Congress that has thousands and thousands of shelves. So your hard drive is like a bookcase. You put the book up there, you may not need it for a week or a month or even a year, but you know that it's still on the bookshelf when you need to go get it. When you need to retrieve it, you can go to the shelf, you can pull the book off, and you can get the information that you want. Likewise, when we save something to a hard drive, using that as storage, we can go to the hard drive at any time, today or next year, pull off the information that we want as well. Now that, of course, is different than RAM memory. Remember that the hard drive is storage, but RAM memory is not. This is temporary, sometimes called volatile or short-term. It's not for long-term storage. If you want to keep something a long time, you had better not keep it in RAM memory, because as soon as the computer goes off, that information will be lost. This is short-term. RAM can hold file-specific data, like if I'm typing a letter, until I actually save it, that will be held in RAM memory. But it also can contain computer instructions. So likewise, when the computer is trying to figure out what it needs to do, those will temporarily be held in RAM memory. When the computer is turned off, RAM is cleared or reset, so it is not a storage place. RAM is measured these days in gigabytes as well, and the higher number or the more RAM you have, the better your system performs and the more that it can hold at any given time. Think about it this way. Having more RAM is like having somebody who has a better short-term memory. I joke with my husband that I have a 3-item limit in my short-term memory. If he tells me to get bread, eggs, and cheese, and then he adds butter, I lose the last one because I can only remember 3 things at a time. He's better at such things, so maybe he can remember 10 things at a time. That in some ways makes him a little bit more efficient, because he can remember a few more instructions or directions at any given time without having to go back and look it up. RAM memory is exactly the same. But how does this actually affect you in the way you work on your computer? More RAM means several things. It means faster performance, that you can have more open files at one time, that you can work with larger, more complex files, that you can have more programs running at one time. And like having a table to study from instead of a desk or holding a book on your lap, the more RAM you have, the better. Well, let's talk about this for just a second. You get faster performance because instead of having to feed the computer one instruction at a time, the RAM can hold multiple instructions, so the computer can simply access it faster. Likewise, that's why you can have more than one file open at a time, and they can be very complex files, because that can be held in temporary memory. Let's go to my analogy, though. Let's say that you need to go and you need to study, but you get to the library and the library is filled up. Now remember, the library has shelves and shelves of books. That's your hard drive. If you can't find anything but an individual chair, then you're kind of limited on how much you can learn at one time, because you can look at one book that you've gotten off the shelf, but when you're done with that book, you have to go put it back before you can get a second book, because you can only hold one at a time. On the other hand, if the library is empty and you have a really large table, you might be able to pull 8 or 10 or 20 books off the shelf at one time and have all of those books open in front of you. Now you can work a little bit faster and more efficiently because all of that information is right at your fingertips. You don't have to go back to the bookshelf each time you need to get a new piece of information. That's what happens when you have more RAM on a computer system, and why all of these things are true when you While it's important to understand the concepts behind the motherboard, the processor, and memory, the good news is that all that electronics and circuitry stuff is carefully and safely tucked inside the box, and we're fortunate, because normally we don't have to deal with it. What we usually have to deal with are all the lights and ports and buttons and things that we see on the computer itself. So let's take a few minutes to get familiar with what types of things we might see. The CPU, or computer case, will actually have many different lights, buttons, or ports that you can use. Typically, a laptop is actually going to have more than maybe a regular desktop CPU. You're going to have something like the power button. You always have to have one of those. You'll probably have a light that represents your hard drive. You'll have a battery light for your laptop. You might have multimedia buttons. And you're also going to have various different kinds of ports. Now, when we talk about the hard drive light, this is simply going to be a light somewhere on the case or on the CPU. The most important thing to recognize about this is when that light is lit, it means that the hard drive is running. In other words, it's spinning and it's actively doing something. It's really important that you do not turn off your computer while the hard drive light is spinning. That can simply cause some damage. So it's an important thing to look for if you're ever having to do what we call an emergency shutdown of your computer. We'll talk more about exactly what that process is later. But let's take a little bit of time to talk about these other options. When we talk about the power button itself, there's kind of a universal symbol, and you can see that represented here. One is actually just a symbol, but the other three are actual buttons off of computers. So they may be different colors, they may be lit up, they may be different shapes, but somewhere on your computer there's going to be a power button that you will use to power up and sometimes to also power down. The power button is a basic component, but so are the ports, which is how you actually connect things to your computer. The things that you connect to your computer, to the CPU or to the box, are called external devices or sometimes called peripheral devices. There are many types of peripherals, and there are many types of ports to go along with those. Some of the ports are specific to certain types of devices, and others are more generic and connect different types of devices to the same port. Remember that when you're connecting things to a computer, there is often a right side up for a connection. They can't just go in any old way. And maybe most importantly is never force a connection. If you try to force a cable into a port, you can damage both the port and the device cable. There are several types of ports, and this can be very confusing to people, so we want to go over some of the basics. There are actually many more types of ports than this. Some of them, though, are older, and you don't see them very often, so I didn't want to confuse you with things you probably won't see. Some of them are also very specific. What we're covering here are the ports that will be important for you as a new computer user. They include a monitor port, a keyboard and mouse port, a printer port, a port for speakers and microphones, something called FireWire, and something called USB. A monitor port is fairly small, almost rectangular, and it can have little holes in it. Now again, we're not going to get into the specifics about what all of these different things are called, but here's an example of a monitor port. Make sure that when you connect a monitor cable that it's right side up, because if you look at the little holes, you see that they are not consistent, and there definitely is a right side up and down. You'll also see that there are little holes on either side into which you can screw in the monitor cable so it doesn't come loose or disconnected, causing your monitor to black out on you. These are examples of keyboard and mouse ports. Keyboard on the left, mouse on the right. They look very similar, but again, they are slightly different. And if you ever plug your keyboard into the mouse port, you'll know because they just don't work right. Again, you will see that there definitely is an up and a down. Even though these look like they are round cable connectors, there is a top side. It's easy sometimes to just simply rotate it around until you can feel that it kind of gets ready where you can push it into place. We're seeing fewer and fewer printer ports, but it can be a larger port than the monitor port, with more pins, as they say, or more holes. And again, it should be labeled, like many of these ports will be, that it is for a printer. These days with multimedia, wanting to use speakers and or microphones is important. These are very typical audio-video kinds of connections that you probably have on your portable CD player and other things that you've used. And the port itself can actually be on the back of the computer, where a sound or video card may go, or it could also be on the front of your computer. There may be several different ports that all fit the same type of thing. Usually they're marked separately for the speaker and the microphone. So make sure that you put it into the correct one. It's not that it will necessarily damage anything, it just won't work. So if you plug in your microphone and you find that you can't use it, or you plug in speakers and you can't hear anything, try another port. FireWire is a high-speed connection used for things like audio and video especially, and it's kind of a specialized type of port. Not all computers have them. Usually it needs to be higher end or set up specifically to do multimedia, audio, or video. In some ways, though, I have saved the best for last, because USB, which is a universal serial port, is actually the most popular type of port these days. It hasn't been around very long. The current standard is called USB 2 as opposed to USB 1. USB 2 is faster. So if you can buy USB 2 devices, that's the better choice. There are two different types of connectors that you can see here. One is for kind of internal devices and the other is for more portable devices called USB-A and USB-B. But the important thing is that the USB port has actually replaced many of these other ports. We aren't seeing as many monitor ports, keyboard and mouse ports, or printer ports as we used to, because those devices actually can all use a USB port. If you go down to the office supply store and you buy a printer these days, it probably will have a USB connection. When you go to buy a new computer, you actually will probably not see a printer port. Only older computers have them. So as I said earlier, don't panic if your computer doesn't have all of these ports. Probably what you'll start to see is more USB. Not that long ago, maybe 8 or 10 years ago, we only had 1 or 2 USB ports on a computer. The ones that you see nowadays have usually 2 or 4 on the front and maybe another 6 or 8 on the back. So USB ports really are becoming very popular. That's why I like to say it's becoming a USB world. Most computers today have multiple USB ports, both on the front and the back of the CPU. Many of the old proprietary ports have been replaced by these USB ports. As I said, printers, keyboards, mice, storage like external hard drives, and many other devices now come with USB connections instead of the old proprietary ones. And even though we're not going to talk specifically about it in this course, also remember that many devices are now becoming wireless. And when it's wireless, you may or may not actually need to connect it at all. Some things like Bluetooth may be built into things like your laptop, so there's nothing that you're actually going to see. It just happens to work. Others, though, will be wireless, like a wireless printer, but you may still need to put some type of a receiver into your CPU, into the USB port. The important thing to remember is that whether it's a cable or through some type of airwave, you need to have some type of connection between hardware and your CPU or your computer. If it's going to be wireless, there needs to be some mechanism for that connection to happen. So how do you find what you're looking for? Well, every computer is going to have buttons, lights, and ports, and they're all going to be in a different location. Most desktops have front and back ports only, so you can kind of limit it to at least 2 of the 4 or 6 sides, if you will. Laptops, of course, can be a little more tricky. They can have any of the 4 sides, or above the keyboard when the lid or the monitor is open. So sometimes on laptops you're going to have to search around, everywhere probably except on the bottom. Sometimes your ports and cables can be color-coded. So when you're trying to figure out which one is the mouse and which one is the keyboard port, it may be that one of the cables has a purple end on it, and so does the port. That sure makes it easy. Most are also labeled with some type of an icon. Now, if you're like me, you have to turn on a light and get pretty close to be able to see them, but you often will have a little keyboard, a mouse, a speaker, a microphone, a monitor, a printer. Those types of kind of generic universal icons may be printed somewhere on the case that will help you determine which port it is that you're looking for. And last but not least, you can always refer to your Quick Start Guide or the user's manual that came with your computer. It should have several diagrams that will identify all of the buttons, lights, and ports that are available for your particular system. At this point, you should be comfortable with the fact that you need some basic parts to have a usable computer, mainly a CPU with a motherboard that holds the processor and RAM, and probably a keyboard, a mouse, and a monitor so you can see what you're doing. In the next chapters, we'll take a much closer look at mice and keyboards and how to use them. But for now, let's get you going on the computer itself. Let's work through powering the computer on and off, what it entails, and what options you may have. This is actually called the boot process. The boot process is, as you might guess, the process of starting the computer. The computer must go through specific steps in order to be ready to perform computing functions. Remember, we have all of those electronics sitting in there, but as they're sitting in there, they really don't do anything. They have to recognize certain things. When you power on the computer, this process starts. The computer will load initial instructions from the ROM memory, detect the operating system and any attached hardware, start certain computer applications that it needs in order to get ready to work, and then you're all ready to go. Now this, of course, is a simplified explanation of what goes on. It can be very, very detailed, but for our purposes, we can kind of narrow it down to these 4 things. Powering it on, loading initial instructions from ROM, detect the operating system and hardware, and then start certain computer applications. It's easy to remember what the boot process is if you think about waking up in the morning yourself. What do? Well, we all do it a little bit differently, but basically the alarm clock goes off, or if it's a nice day on a weekend, you get to wake up on your own, but you might kind of open up one eye and the first thought might be, who am I? And what day is it? And then it might be, well, okay, let me get started. I need to sit up and put my feet on the floor. I need to remember that I have certain things going on, and then you go through certain processes. I don't know what those are, and I don't want to get into them, but maybe you brush your teeth, eat breakfast, feed the dog, get dressed, those types of things. The boot process is exactly the same way, and it happens the same way every time. There are actually 2 different ways to boot a computer, though, called a cold boot versus a warm boot. A cold boot can also be called a clean boot. This is what happens when you first power on a computer after it's been turned off for some period of time. So you've been gone for the weekend, you come back to work, and you push the power button on your computer. That's what we're talking about. A cold boot ensures that all of the temporary memory and internal settings have been completely cleared. Basically, the computer has been in a powered off or an at-rest state, and you're going to wake it up from the beginning. The way to do this is to press the power button. Now at this point we're talking about starting the computer, not restarting or turning it off. We'll get to those things in just a little bit. So for now, a cold boot can only be completed by pressing the power button. A warm boot, which can also be called a reset, is a little bit different. This is restarting the computer without completely turning off the power. This does still erase RAM memory and reloads the operating system. You might want to do a warm boot if your computer all of a sudden is acting funny, because possibly you have too much stuff in RAM. The RAM memory is getting a little bit confused and you simply want to reset it. Another time when you might do a warm boot is after you've installed some software or an application. The computer may ask you to reboot the computer, again to make sure that everything is set up the way that it needs to be and it has kind of a fresh start. In order to do a warm boot, you can choose restart once the computer is already on, or you can press a keyboard combination known as Control-Alt-Delete. Now remember, we can't do a warm boot if the computer is already off. A warm boot is something we do once the computer is on. Now remember, when you first power on your computer, you're not going to see anything on the monitor yet. You're going to push in the power button. You should see the power light go on the CPU case. You'll probably hear your hard drive start to spin up, and the computer's going to start going through that boot up process. You will probably also see some text flashing across your screen. This is all of those startup instructions, a lot of which will be very technical, and usually you don't need to worry about it at all. If you want to read it and try to make sense of it, feel free to do so. But basically, the first part that you're going to be concerned with is when it starts to load the operating system. In this case, we're going to be loading Windows. So I'm going to press the power button, get it through the initial boot up process, and let it load the operating system for us. As the operating system loads, it'll tell you to wait, it'll give you a welcome, and as long as you see the little spinning donut, you'll know that Windows is loading and you're okay. You'll hear Windows theme music as the operating system loads, if you have speakers and they're turned on. Depending on your computer, it may take a few seconds to even a couple of minutes for the computer to load. It really depends on how much hardware you have, the operating systems, and all kinds of technical stuff in the background. But ultimately, you'll end up at the Windows desktop in this case, and this is a good sign. Congratulations, you've just successfully powered up your computer. Now the question, though, is what do we do if we want to do one of those warm boots or we want to reset the system? Well, there are a couple of ways to do this, but what I'd like to do is to show you the Start button, which is on the lower left side of your screen. Now, whether you're using Windows 7, Windows Vista, or even XP, you're going to have this Start button, even though it may look a little bit different. So find the button on the lower left that either has the Windows icon on it or it actually says Start, and give it a single left click with your mouse. A menu will come up, and you'll notice near the bottom right-hand side there is some version of a button that says Shut Down. Again, this happens to be Windows 7, and so mine actually says Shut Down right on the button. If you have a prior version of Windows, it may say something different, but there will also be a little right arrow. If you do a single left click with your mouse on the arrow, this is where you get to see a lot of your options having to do with shutting down, powering down, and switching users. At the top of the menu, I see an option to switch users as well as simply logging off. Now these are concepts that we haven't gotten into yet. We'll talk about these when we set up user accounts as well as talking about networks. So I want to talk about just a couple of the other ones that are a little more basic at the moment. First of all, we do have the opportunity to lock a computer. Locking a computer simply puts up a login screen so that anybody else who walks by the computer can't use your computer without permission. This is a perfect thing in a business environment, probably not necessarily in your home unless you don't want other people, like the kids, using your computer. We were talking specifically, though, about warm boots and cold boots, and this is where I can go in and actually restart the computer. If I click on this Restart option, you'll see that it actually tells me closes all open programs, shuts down Windows, and then restarts Windows again. Once you click on the Restart option, you're not going to have to do anything. You're just going to sit back. The computer will go through both the shutdown and the reboot process on its own. You also will see an option for making the computer go to sleep. This is an interesting thing that has more to do with power consumption. It actually saves anything you have open on the computer and puts the computer into a low power mode. When you come back and want to get to work, you can simply press your Escape or your Enter key on your keyboard usually, and it will come back up with all of your applications and windows back open. This is great for people who know they're not going to be working overnight, but they don't want to keep the computer completely on. If you're using a laptop, you may also see something called Hibernate. Hibernate actually is something that is between sleep and a complete shutdown. The sleep mode simply puts you into a low power state, but the computer technically is still on and using some power. Hibernate saves everything, but also completely powers down. The nice thing about both sleep and hibernate is that when you bring them back up, they resume exactly where you left off. And that's the benefit of using either one of these instead of actually shutting the computer down. We'll talk a little bit more about this when we get into using applications and multitasking. So let's take a look at a couple of these options. I'm going to go ahead and restart the computer. Remember that once I click this, the computer will shut itself off and come back up. Let's watch this process. As the computer begins to reload itself, you'll see the same things that you saw when you did a cold boot. The process is the same, except that the warm boot is once we have the computer already running and we want to restart it, as opposed to starting it from scratch, if you will. There you go. Now you've done two things. You've actually powered up the computer and done a cold boot as well as a warm boot. The last thing for us in this particular section is to go ahead and go through a shutdown process. This is likewise very simple. We're going to click on that Start button, come to our Power options, and because I'm on Windows 7, I can simply click Shutdown. If you're on a prior version, you'll have to use that arrow and choose Shutdown from there. We'll go ahead and shut it down, and then we'll be all finished with this chapter, and we'll be ready to move on to mousing. In this case, you can see, or actually maybe you can't see, that we've actually completely powered down. The monitor has gone to black, and this is when you know that the computer is completely and safely turned off. Good job!